In this lesson, we're going to look at how to create lines that are parallel and perpendicular to other lines. We have been looking at writing equations in slope-intercept form and in point-slope form. And we're going to be using all of that today to look at parallel and perpendicular lines. Okay, so first we're going to look actually at a website. I'm going to escape out of this for just a minute and pull up a website. What I'm going to do is I'm going to use this equation that's right here, y equals negative 2/5 x plus 4, and I'm going to put it into a website called desmos.com, and here it is. It's a graphing calculator here. And if you look over here, I've already typed in the equation, y equals negative 2/5 x plus 4, and you will see here on the graph that it is graphed for you. So we have learned about slope-intercept form, that 4 is the y-intercept. Notice it crosses at 4 on the y-axis, and the slope is a negative 2/5, which means it goes down 2, 1, 2, and to the right 5, 1, 2, 3, 4, 5, down 2, to the right 5, and that slope continues over and over again. So you can see that this line has been graphed. What we want to try to do is create an equation that is parallel to that line. So let's think about that for a minute. If we want the line to be parallel, let's just draw a line that looks parallel. We know that the slope was 2/5 and 2/5. So let's just start somewhere else. Let's say we start here where the y-axis is 2, where the y-intercept is 2, and we go down 2 over 5. We made a line right there. Now that's not a very good straight line, but you can see the idea. They're trying to make a parallel line. So for parallel, we probably want to keep the slope the same. So I can go back over here to this place, and I can type in another equation. Y equals, oops, that's pi. Back up the buggy, not another one. Let's see, where's my backup button? There it is. And where's my equal sign? There it is. So y equals, and let's try the same slope, which would be a negative 2/5. And then we want to do x. Here's x. So that made the same slope. Notice right now that the line pops up and the y-intercept is 0. Because in my equation, I haven't given it a y-intercept yet. So it's an understood 0 y-intercept. Now we can just make the y-intercept wherever we want it to be. It could be at 0. Or if we wanted to, we could give it another y-intercept. So let's say plus, where do we want it to cross? Let's say we want it to cross at 2. I can say 2 and it pops up on 2. So from this you can notice that to make a parallel line, the slope of the line is going to stay consistent. The only thing that changes is the y-intercept. So let's back here what we were doing here. Input this equation into desmos.com. Create another line that is parallel to this line. Write the slope of the line parallel to the given line. So if you're taking notes, down there at the bottom box, to find a line that is parallel to a given line, the slope will be the same and the y-intercept changes. So the slope would still be negative 2/5, and we just decide where we wanted to cross the y-axis. So that's not too difficult. Now, it was easy when we were looking at a graph, but let's take an equation here, and we want to write the slope of a line parallel to this given line. So first of all, we need to figure out the slope. You really can't figure out the slope until you have put the equation into slope-intercept form, which we have been practicing on. To do that, we want the y term on the left, we want the equal sign, then we want the x term, and then we want the constant on the left side of the equation. So if you look up here, the only term that we need to move is the x term. It needs to jump the fence. It needs to come in right here and move from the left to the right side of the equation. When it does that, we have to use our inverse operation. So instead of a positive 3, it's going to make it a negative 3x. So the y stays on the left. The 3x jumps the fence and becomes a negative 3x, and it tells the 27 to move over. So here it is in slope-intercept form. Once you have it in slope-intercept form, you can simply look at the slope right here. So what is the slope of any line that would be parallel to this one would be -3. So we just put it in slope-intercept form to figure that out. Let's try again. Here's another example. And before we can decide what the slope is, we need to put it in slope-intercept form. The y term is on the left where we want it, but the x term is on the left, and we want it right here. We're going to tell the 17 to scoot over. Okay, so when we do that, the x becomes a positive x. So we have 2y equals x plus 17, and we understand that there's an invisible number 1 in front of that x. Y is not by itself yet because y is being multiplied by 2. So we want to divide all three terms by 2. And when we do that, the 2's are going to cancel out. And we find here that our slope is 1/2 x plus 17/2. So this is what we were looking for, was the slope, the 1/2 x. So once you put it into slope-intercept form, all you have to do is look at what's in front of the x term, and that is our slope. So we know that any line equation that we want to write needs to have the same slope. Now we're going to take it one step farther. It says write an equation for the line that is parallel to the given line that contains this point. So now we want a line that's parallel, but we want this point to be part of the line. So here we have 3 steps that we're going to follow to do that. First, we need to figure out the slope. To do that, we write it in slope-intercept form, like we just practiced. So up here in this equation, the x term, it's in standard form right now, so the x term is going to have to move over here and tell the 10 to move over. That would give us a -2y. The 5x moves from the left to the right. It becomes a -5x. He tells the 10 to scoot over so he can take his place. Now we have to divide all 3 terms by -2. And when we do that, we find that y is equal to, we have 5/2, but we have 2 negatives, so it's a positive 5/2 x. And then 10 divided by -2 is -5. So now we know the slope. So you have to find the slope first. So by putting it into slope-intercept form, we have discovered that the slope is 5/2. That took up a little bit of room, so I'm going to erase that and let my animation go. There's the equation we came up with. Now we're going to use point-slope form, because now we know the slope. M stands for slope, is 5/2, and we have a point. If we have a point and we have a slope, we can use point-slope form to write a new equation. So we have learned, this is just a review, remember you take y minus y1 equals the slope times x minus x1. So we're going to be plugging in numbers to here, and to here. We've already practiced doing this point-slope form. So here we have the slope that we're going to plug into m. We're going to do the opposite of the x here and the opposite of the y here, and we're going to plug it in. Okay, so when we plug all of that in, it looks like this. So it was a -5y, so we do the opposite of that and we put +5. We plug in the slope to m, and then here for the x, we do the opposite of the x. It was a +3, so we plug in a -3. So I hope you remember point-slope form. And now we just have to put it into slope-intercept form by, first we do the distributive property. So y plus 5 equals, first we do 5/2 times x. Looked funny. And then we do 5/2 times a -3. That would be a -15/2. Now we have to get y by itself, so we have one step left to go. So we have to subtract 5 on both sides. Since I have a fraction on the right side with 2 as the denominator, 5/1, 5 can be written as a fraction as 5/1, but if I want to make that with a denominator of 2, that would be 10/2. So I am subtracting 10/2 on both sides. 2 negatives, so same signs, add and keep. So y is equal to, here was our slope, 5/2 x, and then I have a negative 25/2. Hopefully you remember how to do that from our previous lesson, and we're just using what we've learned before to find a line that is parallel. Okay, this time we're going to look at perpendicular lines. Now, perpendicular lines are lines that form 4 90-degree angles. So let's think about what we would need to find a perpendicular line. This says 2x plus 3y equals 7. First of all, let's put this into slope-intercept form. Let's get the y by itself. So we're going to move the 2x term to the other side. So 3y equals a negative 2x. And we told the 7 to scoot over. Now we divide all three terms by 3. And we have y equals a negative 2/3 x plus 7/3. Negative 2/3 x plus 7/3. Hope I can remember that long enough to put it in Desmos. So let's pull up Desmos here, if I can get it back up. Okay, I'm going to erase these. I'm going to start a new negative 2/3 x plus 7/3. So we're going to type in y equals negative 2/3 x minus 7/3. Okay, so let's look at the line here. Let me make sure I got that right. Oh, plus 7/3. So it was a plus right here. So let's go back and erase this and put a plus sign. Okay, so let's look at the line here. We have a y-intercept of about 2 2/3. 2 1/3, I'm sorry. And the slope is negative 2, 3. So we went down 2 and over 3 for our slope. Now, if we want a line that's perpendicular, now it really doesn't matter about the y-intercept here, because we could make a perpendicular line up here. We could make a perpendicular line actually on the same y-intercept if we wanted to. So the y-intercept's really not going to matter because it could be moved anywhere along that line. But let's think about what happens to the slope. Instead of being a negative slope that goes downhill, this time it's going to be a positive slope that goes uphill. So we know we want to change the sign of the slope to positive. And then what's going to happen is it's going to become the opposite. Since this was down 2 to the right 3, we want to do the opposite and go, what we're going to do is take the reciprocal of it. So the reciprocal of 2/3 is 3/2. So this time we're going to go up 3. So 1, 2, 3, and to the right 2. And that's going to give us a line that is perpendicular. That looks much more perpendicular than the lines I was trying to draw. So let's see, let's type this in where they can do a much better job at it than I can trying to freehand it there. So let's type this in. So y equals, what happens if we take the opposite? Because instead of a negative slope, we want to have a positive slope. So there's a positive 2/3 x for the slope. Notice right there, boom, it pops up with the slope as the opposite reciprocal, and you can tell that it is perpendicular. Now we can put the y-intercept wherever we want to put it. It doesn't matter. We could have the same y-intercept, x divided by 3, and it crosses at the same place. Or we could do a different y-intercept. Y equals 2/3 x, and we could give it whatever y-intercept we wanted. Let's say we want it to cross at -1. There is another line that is perpendicular to the green line, just a different y-intercept. So what we had to do is simply make the opposite reciprocal of the slope, and that gives us a perpendicular line. So let's look back here. To find a line that is perpendicular to a given line, the slope will be called the opposite reciprocal. You find the slope then if it's negative, it becomes positive. If it's positive, it becomes negative, and you flip it. That's what the opposite reciprocal means. And from that, we will have a perpendicular line. So let's try this one. Write this equation in slope-intercept form. It's in standard form right now. So the x term is going to have to jump the fence and go over here. It goes from a positive 4x to a negative 4x, and the 1 scoots over. Here is our slope. It's a negative 4 over 1. We want the opposite, so it's going to become positive, and we're going to flip it. So that would be a positive 1/4. This would be the slope of any line that is perpendicular to that one. You just take the opposite reciprocal once you find the slope. So let's try this one. This time the x needs to come over here and to the right side, and the y needs to go to the left side. They both have to jump the fence. Well, we have a negative 8x. When it goes to the right side, it becomes a positive 8x. The 4 is in the right place. And the y needs to go from the right side to the left side, so it goes from a negative to a positive. Here is our slope, 8 over 1. We want to take the opposite reciprocal. So instead of positive, it's going to be negative, and reciprocate it into 1/8. So the slope of a line that would be perpendicular would be negative 1/8. So let's see how we would use our point slope form. So here we have an equation. We want to find an equation of a line that would be perpendicular to this one, but contain this point. Always look to see if you're looking for perpendicular or parallel. Parallel, same slope. Perpendicular, the opposite reciprocal. So first we need to put it in slope-intercept form. So it's in standard form right now, so the 2x is going to have to go to the other side. So that would give us a negative 2x, and we tell the 7 to scoot over. Now we divide all three terms by 3. And this is what we're looking for right here. Negative 2/3 x. Here's the slope that we're looking for. So negative 2/3 is our slope in the original equation. We want to take the opposite reciprocal. So if the slope here was a negative 2/3, and we're doing a perpendicular line, we want the slope of a positive 3/2, the opposite reciprocal. So here we have our slope. Here we have the point that we also want to go through that line. So we're going to use our point slope form because we have one point and the slope. Again, we're going to plug that in. Remember, it's y minus y1 equals the slope times x minus x1. And we're plugging in numbers, the opposite of the y here, the slope here, and the opposite of the x here. So when we plug in those numbers to point slope form, you will see that we put the opposite of 5 right here, made it a negative 5. We put our perpendicular slope here, and we did the opposite of the x right here and made it a negative 4. So we plugged in those three to point slope form. Now we need to convert it back into slope-intercept form. So our first step, as we have learned, is to do the distributive property. So y minus 5 equals 3/2 x minus 12/2. Okay, one step left to do. We need to add 5 to both sides. Again, 5 over 1, if we want to make that into a fraction with the same denominator, it would be 10/2. So we're going to add 10/2 to both sides. One is negative, one is positive. Different signs subtract. So I'm going to have a negative 2/2, which would be simply a negative 1. I had a negative 12/2 and a positive 10/2. That equals a negative 2/2, which is a negative 1. So here's the equation of a line that would be perpendicular to the first one. This one is on the assignment that you're doing. It's on the punch line, number W, or letter W. So first we want to find the slope. It is already in slope-intercept form. So we see the slope right here is 3 over 1. We look to see what we're looking for. We're looking for a line that's parallel, so same slope. So our slope in our new equation is still going to be 3. And here's our point. So we're going to plug those numbers into point slope form. So y, the opposite of the y would be a negative y, equals the slope times x and the opposite of the x, which would be minus 2. We're going to do the distributive property. That would be 3x minus 6. We're going to move the 7 to the other side by adding 7 to both sides. So y equals 3x plus 1. Using all the things that we've been talking about with point slope form, slope intercept form, distributive property, all of those things together. Okay, let's try one more. This time it's perpendicular. This one's also on the assignment that you're working on. We're looking for a perpendicular line, so we want to use the opposite reciprocal. It's already in slope-intercept form. We have a negative 1/3 for the slope here. But we want to take the opposite reciprocal, so it'd be a positive 3/1, or we can just use 3. So here's our slope. Here's our point. We plug it into point slope form. Y minus 5. Okay, sorry about the interruption. So we do y minus 5 equals the slope of 3, and then x, the opposite, which would be a minus 2. Our next step is always to do the distributive property. So y minus 5 equals 3 times x, which is 3x, and 3 times negative 2, which is minus 6. Now all we have to do is move the 5 to the other side of the equation using our inverse operations. And we see that the new line would be y equals 3x minus 1. You probably like it without fractions. There's all the steps we just did. 3x minus 1. Okay, so what you need to remember is that parallel, we use the same slope. Perpendicular, we use the opposite reciprocal. Good luck with parallel and perpendicular lines.